got to know what is the complex number. Complex number is a mixture of a real and imaginary number. It is assigned by the letter z, and z equal to x plus iota y. This is iota, I is equal to, that is under root minus 1, also known as iota, right? So this is a real part of z, and this is what you call imaginary part of z, right? So in any complex entity, there is two parts, real and imaginary. The main key point is here, if z is purely real number, then only x part will be alive, so y shouldn't be there. Therefore, if z is purely real number, so its imaginary part of z is 0. This is the condition. And here, number 2 condition is, if z is purely imaginary number, then its a real part of z should be 0. It's okay. This implies y is equal to 0, and s stand for sine. So that is third part, that is cis form. Another well-known form that we say r e to the power iota theta. E to the power iota theta, this is also known as Euler form. Argand plane, this is also known as Argand plane, Argand plane, and also called sometimes complex plane. Although this is here first quadrant, second quadrant, third quadrant, fourth quadrant, these quadrants are differ from trigonometric what we studied in 11th class. So in trigonometric quadrants, that is another thing, and here this is complex plane, Argand plane. This plane can be formed by the two different lines, that is, one is a real line, this x-axis is called here a real line, and y-axis is called imaginary line. If we represent z here, then that is, as I have already told here, that is x is the real part of z and y is the imaginary part of z. So this part is x and this point is y. This is also, you can say, coordinate here, but this is a way to represent z, also called ordered pair form. As I have written here, different form. One of the form is also ordered pair form, z equal to x comma y. It represents that there is x is the real part and y is the imaginary part. The distance from origin, it's a 0. If you say 0 is also complex number. It can be real number also. It can be purely real also. It can be purely imaginary also. But 0, you say, 0 can be represented as 0 plus iota 0. As 0 lies on a real line and as well imaginary line, 0 is a complex number. It's okay. 0 can be said to be purely real. Why so? Because imaginary part is 0. 0 can be said to be purely imaginary. Because why so? Because its a real part is 0. Right? So 0 is a complex number, only complex number which can be said to be purely real as well purely imaginary simultaneously. Anyhow, so from 0 complex number, what the distance of any complex number z, that is the mod z. If you say this is length is x, this is length is y, by using Pythagoras theorem, we can found that mod z equal to under root x square plus y square. It means under root of real part of z whole square plus imaginary part of z whole square quadrant. So if this is z lies in first quadrant, z may lie in second quadrant, z may lie in third quadrant, right? And z may lie in fourth quadrant. First quadrant. Is it visible? Okay. So if z lies in first quadrant, a real part is also positive, imaginary part is also positive. This implies that theta equal to tan inverse y by x. Let me look at this. This is z and this what you call theta, and here that is x comma y. Right? Now second, if z lies in second quadrant, quadrant, then x is negative and here y is positive. If let me draw the second quadrant here, that is, if z lies in second quadrant, that is x, and here somewhere z. So this we say x comma y. So what do we find here? That x is positive and here y is negative. This is x-axis, this is y-axis. X is negative and here that is y is positive. So this is we are talking about this angle. So this angle can be evaluated as, these two angles are supplementary. So let this be alpha here. So if here this is theta is required, so we can say theta equal to pi minus tan inverse y upon x. As x is negative, so you have to put here mod x. Okay, let's take example to understand about this, how theta becomes pi minus tan inverse x. Let's take example. Suppose z equal to, we say minus 1 plus iota. Where it locates? Minus 1 is the real part, negative, plus iota, that is imaginary part. So that is positive. So it lies in second quadrant. We can say theta equal to, what do you say, pi minus tan inverse, that is, 1 upon minus 1 mod. So what do you call? Pi minus pi by 4. Okay, so pi minus pi by 4. This is pi entire angle and pi by 4 this angle. So 4 minus 1, 3 pi by 4, we can say. This is our final answer. 3 pi by 4. This is one of the example. Later on we will discuss more example to understand complete idea of first, second quadrant, third quadrant and fourth quadrant. Anyhow, the angle is of any complex number, this decides the location where it is locating. So if we get the idea, so where in which quadrant complex number falls, then we can find the angle properly. As you know, you call this is a principal value of argument. And here one point you have to note down that the principal value of argument lies between this in first and second quadrant like this. If in third and fourth quadrant, then you have to go like this one. You say clockwise direction. This is the anti-clockwise direction. This is clockwise direction. So theta, what we say argument of theta, that belongs to minus pi to plus pi. Here in any one of the position you have to put in any one of the boundary you have to put either open interval or close interval, right? So due tradition we use pi at close interval and on minus pi that we say open interval. So theta belongs to minus pi to plus pi, left half open interval we can say, or theta belongs to minus pi to plus pi, left half close interval. Okay, so come to the point. Now we go for third and fourth quadrant. So where is this? You can note down. Okay. So I will erase this much only. Let me erase this part also. This is very helpful. That lies in third quadrant, you will say. Third quadrant, third part. And here there is fourth part. Z lies in fourth quadrant. Fourth quadrant, right? And this is in third quadrant. If Z lies in third quadrant, Z is here. So if Z is here, then you can't cross the angle pi, because this will breach the idea here. As theta, principal value of argument of Z, we have to go for minus pi to plus pi only. This is the condition over here. So to understand this, you can't go beyond pi. So you will have to compel to come over here, because minus pi to pi here the angle is over here. So we have to go like this part, this angle which is required. So this is theta here, or you say let this be alpha. It's okay. Here in this x and y, both of them are negative. X is negative and y is also negative. So theta equal to, what do you say here? You have to go for this entire angle is minus pi. So from minus pi, you have to add this part theta. So minus pi plus tan inverse y by x. Here in both of the part, imaginary part of z and real part of z, in both part you have to apply a mod, so that we get this within this interval theta lies between minus pi to plus tan inverse y by x. Okay. So fine. Later on we'll take example to understand complete idea. Anyhow, if z lies in fourth quadrant, minus point. If z lies in fourth quadrant, then what? So z here, this is x, and this what you call y, right? This what you call y, and here this is theta. So what we say here? Here x is positive and y is negative. So theta equal to minus of tan inverse y upon x. As x is positive, so no need of putting or mod here. You have to put y mod here. Tan theta equal to of note on find the argument of here x is also 0, y is also 0. So you say theta equal to tan inverse, if you write here, that is 0 by 0. It's okay, which is not possible. This 0 by 0 is said to be indeterminate form. Indeterminate. So here in other way you can say the argument of complex number is not defined. What do you have to say? Argument of 0 is not defined. Express mod x plus iota y in terms of a plus iota b as complex number. E to the power iota theta, that is cos theta plus iota sin theta. You all know well. We have discussed it. Yeah. Now if you replace this theta with 2 theta, then what you will get? E to the power 2 iota theta is equal to cos 2 theta plus iota sin theta, right? Now replace this theta with iota x. What do you find? E to the power for theta, what do you say? Iota x. And when you substitute this, then iota x square, that is minus 1. So what we say here? Cos minus theta, cos 2 iota x and plus sin 2 iota x, and this iota square become minus x as e to the power minus 2x equal to cos 2 iota x plus iota sin 2 iota x. So similarly, as this is equation 1, if you replace this theta with minus iota x on this one, so you will get the same result. Replace x as negative, you can say e to the power 2x equal to cos 2 iota x, and here sin minus theta is minus sin theta, so minus iota sin 2 iota x, right? So in this way, if you add this 1 and 2 both of them, then what you will get? The value of cos 2 iota x and sin 2 iota x, you will get this. Now replace this results with x with replace this entire result of x with y. What do you get? E to the power minus 2y minus e to the power 2y upon 2 iota for sin 2 iota y, and for cos 2 iota y, e to the power minus 2y plus e to the power 2y upon 2. And solving this, you will get the real and imaginary part separated. This is the result. So in this way, you can convert this as a plus iota b. What is a? This one is a. This part is a, and this part you say this is b, right? This part is b, correct? So this is your complete answer. Similar type of questions we will discuss more in next video. So if you like this video, please like it and subscribe it, and don't forget to press the bell icon button so that you get more videos, more interesting videos of the same type in the next session. Anyhow, in the next session we will discuss geometry of the complex number. So don't forget to come in the next video. Okay, thank you. Thank you.